The sine function is not one-to-one. By definition, well, one-to-one, let's test using a horizontal line test because it's easy to see that way. If we draw a sine function, let's say, okay, just say from one period, right? One period, from 0 to 2 pi. And you can extend this pattern to another period, like from 2 pi to 4 pi, etc. So we can draw the sine function as many periods of sine function as possible. So you will see that, okay, here's one period from 0 to 2 pi we see. And then, but doesn't matter, you just, it's defined on all real numbers. You can extend it right to the left as well. So you just do this, and then you can draw any horizontal line. Let's see if we draw a horizontal line in a blue color. So I just, it definitely intersects with, yeah, it happens at least once, right? So of course, can be many times. If you draw a horizontal line, for such a line, for this case, for example, if y is half, yeah, if it happens once, it violates already the one-to-one as a definition of one-to-one function. So whenever there is such a case that a horizontal line intersects a curve more than once, then this curve cannot be one-to-one. So, and we know there is a sufficient condition for a function to be one-to-one. So let's restrict the function so that on a sub-interval of the real number line, so let's make it a one-to-one. That is, if we just remove some part, this is one period, but still we can think of one period, for example, from half of pi, right? I just go and remove, this is a negative half of pi to the positive 3 pi over 2. That's still one period. So we just, this is still a 2 pi interval. You see, we can make it a 2 pi interval, right? This is just go here. So from negative half of pi to 3 pi over 2, that is still a one period. But I will look at this one period. So on this interval, it is still not one-to-one, right? It's one complete cycle of sine function. It's not one-to-one because easily you can still use a horizontal line test. So if you use a horizontal line test and there exists at least one horizontal line that intersects the graph more than once, so it is not one-to-one. And then we can think, if we think of the sufficient condition, if a function is strictly increasing or strictly decreasing, it has to be one-to-one. So let's only consider this portion of the interval. That is from negative half of pi to positive half of pi. From here to here, positive half of pi. You see the graph is strictly increasing, right? I will use this color from, you see the sine function is strictly increasing from -1 to +1. Or you can look at another interval, for example, for the same, for this graph, if you restrict your attention from positive half of pi to 3 pi over 2, right? If you look at this, the interval defined by this two, then you can consider the other branch, right? So it doesn't matter which one, and either branch will be strictly either increasing or decreasing. So let's just use the first branch. So we're going to clean this up to consider the sine function only on that interval. So now we see it is 1-to-1 because it's strictly increasing. So this sine function, when it's restricted to this interval from negative half of pi to positive half of pi, then the sine curve is a 1-to-1 function, and it's possible to find its inverse. So only this, right? With that definition, we can possibly find the inverse sine function. So you already know the picture for the inverse, so will be symmetric about y equals axis. So you just draw the y equals axis, and then you can draw another function which is symmetric with the sine function, which is this is the sine function, which is original function, right? It's sine defined on this interval from negative half of pi to positive half of pi on this interval. So then we try to find its inverse. Then the inverse will be that reflection of the sine curve with respect to this line, y equals x. So in order to give a better sketch of the inverse function, we're going to give 5 points of the sine function and then find the reversed pair. So here, the sine function from negative half of pi to positive half of pi. You see, at negative half of pi, the sine is -1. At positive half of pi, sine value is 1. So you notice the curve was increasing, right? Increasing from negative to +1. And then we pick a few more points. And when x is 0, the sine of 0 is 0. So we have another point. Then we can add 2 more points. When x, the input is negative pi over 4, the sine value is negative square root of 2 over 2. When it's positive pi over 4, it's positive square root of 2 over 2. So we have 5 points. 5 points is just to get a better sketch. So these are samples from that curve, the sine curve. And those points are in the range, right? From negative half of pi to positive half of pi. And then remember, if A, B is a point on the sine curve, then BA must be a point on the inverse. That means if I put -1 for the inverse function, then the inverse function will take the value negative half of pi. So we just reverse, just treat it for each function. If this is A, you get B. Or the inverse function, if you give B, you will get A, the value A. So it's very easy to find 5 points of the inverse function. All we need is to reverse the values in the above table. So we have, when I put the -1, I should get, so you see this will be the input for inverse function. right? So when I put a -1, what do I get? I should get negative pi over 2. So that's the value of the inverse. Also, this one, if I input the negative square root of 2 over 2, what do I, if I input this for the inverse, I should get negative pi over 4. So the second table is totally and quickly found from the points of the sine function. So this is a table for inverse of sine. So we get 5 points for the inverse sine function. And then we try to show the 5 points. Yeah, quick remark. If the original function, the sine function, right, we restrict the sine function on this domain, and its range is from, so let's write domain for sine function, range for this sine function is from -1 to 1. Yeah, we can show the, so here is from -half of pi to positive half, to, from -half of pi to positive half of pi, right? You can see, and if the points are the sine, so this is the actually crossing this. These are the 5 points. 5 points, yeah. And then for the sine curve, so I just try to sketch 5 points on the sine curve, and then after flipping, we get sine inverse. Sine inverse, if I put in different color, which is let's use different color, let's say red, because those points showing inverse. We got 5 points from the second table, and this domain will be, and that's the range of the original function. And the range of inverse is domain of the original function. So look at that means for the inverse sine, you can only input any values between -1 and 1, including them, right? It has to be a real number that is at least -1 and at most +1 and or anywhere between. So your input value can be this, but your output value will be, yeah, this value, which you can also interpret as some angle in reading measure. So you are looking for that angle in reading measure whose value is the given value. So let's look at a picture of inverse sine. So here is the picture. It's in purple with 5 points, the right points. They are points on this inverse sine curve. And as you can see, when I put a 1, then what you get is positive half of pi. When you input a -1, and your inverse function will give you a negative half of pi. So from this picture, you can see that when you put a 1, you're trying to say, okay, what is the reading measure, right? What is that real number whose sine value is 1? Is such a 1, so it's pi over 2. So you are looking for the y value in this range, only in the range between, that's the interval between negative half of pi and positive half of pi, because that's the range of the inverse. And it is domain of the restricted domain of the sine function in order to get an inverse. Okay, so now we have defined the sine inverse, and you can take a look at this picture, which is plot of the sine inverse. Let's try to use the inverse function we just defined and try to evaluate a number of functions. So if you evaluate the sine inverse function at half, so then you are trying to get the value of the inverse function when the input, that means the independent variable, has the specific input value as half. What is the value of the function? Notice that here's our notation for inverse, right? You see the sign with this -1. It looks like an exponent, but it's not power. It's not a negative power. It's simply a notation for inverse, just like function. And we use this f with this small superscript -1. That is just a name for inverse, not a power. Okay, so if we want to find sine inverse at half, what is the value? So you can think how we did the sine inverse at 1. So that y must be a certain y whose sine value is 1. So you can write in this way. And we know that for sine function over that interval from negative half of pi to half of pi, right? So only at half of pi, the sine is 1. So we actually, but evaluating the inverse, actually we can refer to the function, the restricted sine function, to figure out this y value. Yeah, so that is half of pi, right, in that case. But how about this case? So this case, we think similarly. So y is sine inverse. It's actually what y will have a sine value as half. But you need to look for the y. Y has to be in the domain of the sine, right? This y is actually range of the inverse sine. Y value should be in the range of inverse, because it's sine inverse. But it is here, if we rewrite, we know this it's in the domain of the sine, but the sine is only defined from negative half of pi to half of pi for this sine function to be invertible. So which y in that interval such that sine y is half? Can we tell? And we know y has to be pi over 6. Pi over 6. Okay, so that is yes, so that is the pi over 6. That's the answer. And then let's solve for the second. The second problem, if you want to get the sine inverse at -3, sine inverse at -3, that means you're trying to evaluate inverse function at -3. But what is the domain of inverse? Let's recall the inverse function defined only on this domain from -1 to 1. So for any value smaller than -1, it is undefined. So this value, this inverse is undefined because -3 is not in the domain of the inverse function. Okay, let's look at next example. The arcsine. Arcsine is just another name for sine inverse. So we have two different ways, just like a person may have more than one name. So you can use sine inverse or arcsine. Either name is fine for the same thing. And so if sine inverse at this quantity, square root of 3 over 2, right? If you write arcsine negative square root of 3 over 2, it's the same expression. Yeah, meaning same. Okay, now we want to find sine inverse function at this value. At this value, and so again, we try to evaluate inverse function. So if you want to write this as certain y, right, it should be equal to some y, that's the y value we're looking for. If input is this for the inverse sine. So in order to get this y, and we know that this y must be a certain y whose sine value is negative square root of 3 over 2. So this y has to be in that interval, remember, in the domain of a sine function. So that, yeah, so that this y is in the range of the inverse sine function. So that this y has to be in the negative half of pi to positive half of pi. So which y in that interval whose sine value is negative square root of 3 over 2? So it is negative pi over 6. Negative pi over 6. So we can find the value y is actually negative pi over 6. So how do we evaluate the inverse sine function? It's actually by rewriting it, then you can make sense with the y value, right? So if you see the inverse, this is the y value you're looking for, but you can figure out y by you rewriting it into this form. So the y must be such a number such that sine of y is this. And then we know this y only for this domain of sine. That's right, we define the inverse. So this y has to be from that part of the sine function. And this is the domain of sine. This is also the range of the sine inverse. So this is the range for the sine inverse. It has to be in that interval. That's why we get negative pi over 6. So yeah, with more analysis, you can see Yeah, there's one type, actually problem. Double check. So here is uh the third question. Yes, we say y is the number, where sine value is this. Yeah, all this analysis is correct. So just what is the sine value, which is this? Yes, that's worth double checking, because we all know that if the sine value is positive, right? Square root of 3 over 2. What is the y? Y must be pi over 3, not pi over 6. I'm sorry for that. So because sine y, if it's positive, you remember that's pi over 3. Yeah, pi over 3, then using the odd function property, if it's a sine y is a negative square root of 3 over 2, then the y must be negative pi over 3. Yeah, so we remember some special angles and their sine values, right? So it should be pi over 3. Okay, so very quick check will allow us to fix that. Very easy to fix, as long as we remember that special result, right? So which y whose sine is this value? That's pi over 3. That's right. Okay, so therefore for what y sine value is negative, square root 3 over 2, then it's negative pi over 3. Okay, that's it for the sine inverse.